Okay, so one of the reasons that you should go to as many conferences as possible is because you meet people. And I went to a conference in Tokyo 3 years ago, and not only was that a conference that I got to tack on that trip to the Chris Alexander designed Eshin school outside of Tokyo, but I also got to meet a whole bunch of really interesting people, including a chap named Soren Jones, who is a former, sad to say, colleague of our guest today. Jiten is a consultant at Deloitte, and Soren just switched to Boston Consulting Group. I think there's a victory lap that you can run as a high-end consultant that goes in between these firms. But Jiten represents Deloitte Digital, and I talked with him on the phone. We probably talked for 15, 20 minutes, and my jaw it was on the ground. I couldn't talk anymore. So it's just, well, please talk to the students about what Deloitte is doing with real clients, with this stuff that, as you can see, we got to play with a lot of hypotheticals. And so I'm fascinated to hear about this stuff in the literal world. And so without further ado, Jiten, thank you for joining us.
Hey guys, thanks for the round of applause. So just really quickly, I'm curious, has anyone been in management consulting or taken management consulting experience before joining this type of school? Okay, awesome, because management consultants are absolute snobs about slides, and I didn't have time to format this. I'm super excited to know that you're going to help me out. I work for Deloitte Digital. I'm the lead technologist within Deloitte Digital, focusing and specializing on augmented virtual technologies, basically everything around 3D graphics processing. My own story is a hilarious one. I started my first company when I was 17 because my friends and I were an undergraduate across USC, Vanderbilt, and UVA. And after the first week of class, we all called each other and said, "Hey, how was college?" And all of us said, "This is kind of a waste of time." Like, I was in Jewish humor, German studies, cultural studies. I was in Japanese animation and economics. That was my first semester. I was paying a lot of money to go to Vanderbilt. And I was like, why am I paying this much money to learn about Japanese animation? I have several years, a decade of experience in that. So we tried to start as many companies as possible to try and leave school immediately. We failed a lot. We didn't really get anywhere actually for 2 years. But after around our 8th idea, we came upon something called visual imagery recognition and image overlays, which was a precursor to augmented reality. We found a company called Epson that started making glasses that had miniature projectors in the sides that could create images in front of the user. It was not intended to be augmented reality. This was supposed to be a head-worn television you wore at home. But by hacking out a camera and by making use of the screen in front of the user, we created this augmented reality experience. So that's when I really started building out what would end up being my career in augmented reality, was with the Vanderbilt Medical Center. We built an application that helps anesthesiologists pull information from EHR systems and display them in their field of vision. So if they're in an operating room, they could actually view medical data and even video capture from other medical operating rooms, increasing their reach across 8 different operating rooms as opposed to just one. Ran that for a couple of years, but then realized I was a year away from graduating, so I might as well get my degree. Then I joined Deloitte after that because they were building out and they saw an enterprise appetite for augmented reality or virtual reality and these types of immersive graphical applications within our Fortune 500 base. So the reason why I went with Deloitte is because the way that they structured their innovation team, we had around $1.5 billion as a slush fund sitting on top of our 3 main functions: strategy, technology, and human capital. And that's where we would incubate really cool shit. Things that were starting with basically everything with an acronym: AI, AR, VR, stuff like that. And we would try to apply those to each one of our practices. And if we got these pilots off the ground, if we saw that there was potential for more business, we could then grow those offerings and deepen them and mature them into our core practice. And so around a year and a half ago now, my practice in innovation around augmented and virtual reality became mature enough to where we now moved it into technology as Deloitte Digital. That's where I am today. So what's the next slide? Yeah. I like augmented reality a lot because if you look at these other acronym-ridden technologies, it's pretty far ahead. Virtual reality goes back to late 80s, 90s. Augmented reality as a concept around the same time too, but they came out of the gates real strong before anyone else and really boosted expectations across everyone's imagination. Oh my God, AR and VR is the future of this, future of that. The amount of things that AR and VR has been posited to be able to do is almost anything. Then we realized that it's pretty difficult to actually do these things, and we entered what's called a trough of disillusionment. That's where we realized, okay, maybe I can't do all the cool things I thought I could do because it's really hard to do anything at all with it right now. In the trough of disillusionment, this is the past 2 years where there's been billions and billions of dollars pouring into these technology providers. I used to not be able to sleep well at night because I'm working at a big corporation with other big corporations trying to work on startup technology. That's a recipe for disaster. But I started sleeping easier at night as I saw that Microsoft, Facebook, Apple, Google, and Amazon were all, like the fearsome five of the technology marketplace, were all placing multi-million-dollar, billion-dollar bets. With that much capital at that type of company, those 5 types of companies worldwide, things move very quickly. And so now we're getting to the slope of enlightenment where we're figuring out what works, what sells, what delivers value. And that's why AR and VR is actually a bit further ahead than most of these other technologies, because we're at that point of we knew what we wanted to do, we saw that it wasn't possible, and now we're investing in those missing pieces of the value chain that made it so difficult to do things before. And we'll get into some of those things, but things like making use of assets, integrating the software into an enterprise IT stack. That's difficult work, but now we're at the point where we're doing that. And yeah, compared to other technology market growths, it's ripping ahead. All in all, I sleep very well now, thank you. So we're, again, at a very interesting point. The blue line is some of the 5 big hurdles, big barriers to entry for AR in the enterprise space that I've seen. Let's see. I'm not an accountant, I'm a consultant. And then the green is some of the use cases or some of the big areas that we see of value. And we're starting to realize that some of the barriers are falling, others are close behind, while the uptake in the industries are starting to accelerate. And it's a great point in time to take a look at things because it's encouraging. I mean, as far as some of the barriers, yeah, we'll cover this in other slides. AR is tough to frame in the boardroom when sitting with the chief marketing officer, chief executive officer, information officer, financial officer. It's tough to try and frame these things across different stakeholder groups. And so the way I like to position it is first as information innovation. For me to be good at something, I need a lot of information. In the past, these jobs that we have were taught by either on-the-job training or reading books where you had a collection of knowledge in a physical place that you would have to go to acquire the knowledge and then practice it. Works. But then with the internet and this conglomerate, this syndicated, massive amount of knowledge, we expanded from 1,000 books to billions of web pages, with each containing more knowledge than a book probably would be able to have. So thus the human's capacity or the human's access to knowledge became so much bigger, thus our capabilities to do work also compounded as well. And then we went from having this internet out there with a desktop as a portal to that internet where I would have to still go to a physical location, to having that location come with me wherever I went. And now our interactions are seen on the mobile area as thousands and thousands of touches per day, interactions with data, interactions with information that again, make our lives a lot more awesome. I mean, I can navigate any city in the world now like that. I don't know the city, but I have the information in my pocket. Augmented reality as an interface is going one step further than even having something in my pocket, having these billions of web pages in my pocket. I can now just have that actually contextualized in my world and my environment. It means that I'm no longer accessing information, I'm acting upon information. Information is readily accessible and presented to me as if my own cognition was being engaged. So it's information innovation. And the last part I was talking about, a human interface innovation, that's what AR also is. It's innovating how we interact with both information as well as how we act upon the information. With a laptop, which is say our primary mode of interaction with data right now, especially in the enterprise, you have the human, you have a keyboard and a mouse, you have a program, and you have the data behind that. Couple removed steps. Moving towards mobile, touch, tap, swipe information, that's good. Moving towards AR and VR, these 3D interfaces, now you're actually directly involved with the data. One of the cool projects I'm working on is with a life sciences pharmaceutical company. They're using virtual reality because as part of data analytics, they have over 50, sometimes over 100 variables in clinical trials when they talk about a patient population. Trying to fit all those variables into a 2D graph to spot patterns is notoriously difficult. And so what they wanted to do was use virtual reality to expand the 2D dimension to 3D, where you're literally walking inside a data set. That is the most literal human to data seamless interaction point that I've seen. And it's actually wonderful. So the way that this affects our working memory is very interesting because it allows us to focus more on what we're doing with information at hand as if we know exactly what we're doing, as opposed to having to turn around, acquire the knowledge, and then deploy it. Also, what's not so well realized about augmented and virtual reality is latent analysis. So when I'm in AR or VR, I can track where you look, what you miss, things that catch your eye, gestures. There's a whole suite of quantitative behavioral analytics I can capture, and then I can drive insight around, like for example, a mining company. We're using virtual reality there to recreate their oil rigs offshore and then simulate disasters and see how fast people can navigate themselves out of an oil rig from a core part of the engine room. Well, what we've noticed in one of their oil rig layouts was that people ran right by a big sign that had all the instructions of how to exit. They would run right past it, get lost, come back, find it, and then make their way out. Simply by moving that sign, we're able to save 20 seconds off of people exiting a burning oil rig, which I think is a pretty cool success. Again, that's driven by the fact that we can keep track of where people look, where they move, how long it takes them to do certain actions. Very valuable data. And we're trying not to sell it to the marketers, but they'll probably buy it anyways. Finally, AR is a technology innovation. It's a technology innovation because AR is not just a siloed display technology. A lot of the value of AR is being able to connect to other types of information, specifically within manufacturing. The whole IoT acronym is a great one because it's focusing on gathering information from sensors, from machines, and intelligent technology that is in the world around us. Bringing that information into our own capability to drive decisions becomes a very harmonious relationship where IoT feeds data into AR systems, which drive action back into the facility, which creates a synergistic loop of information to action. At the end of the day, I can gather as much data as I want about a live factory to try and push towards predictive maintenance and things that are moonshots for industry. But none of it matters if the human doesn't do anything about it. And being able to realize IoT or these advanced data analytics types of innovations, the crux of it all is augmented reality. I feel like I had something else cool to say on this slide. Oh yeah, a metaphor. I like to say that natural language is to the human eye in that I can understand where I am based on reading street signs, stop signs, a car coming by. My eyes feed me information about where I am so I can make decisions about what to do with my life. Usually those are good decisions. IoT is to AR as natural language is to our eyeballs. As in, if I'm able to populate my world with more information, AR is my eye set that lets me actually act upon it. I wouldn't know how to find my way here if not for the street signs and the building signs. With AR, I wouldn't even need to check my phone. I could find my way to the building, to the room. I could see how many people are in the room because data is feeding into my AR eyesight. So we did a survey across our client base, which is formidable, and we analyzed the value chain, specifically within manufacturing, although manufacturing is a part of so many industries that it rather became industry agnostic very quickly. And we found that there's a lot of places AR plugs in. So on the right, that's very downstream after things happen, and on the left is upstream activities. In design, and this is where I'm going to stand up on the soapbox and say things, but after this, I'd love to ask questions to gather some feedback. In design, augmented reality is a fantastic tool to be able to see more than one thing without having to refer to a 2D screen, which you lose a lot of context around a product for, or a physical prototype, which incurs cost and time, two of the most harmful things to tell a balance sheet. So using AR, companies like Ford or VW are connecting their design systems, their CAD systems, to augmented reality so that they can visualize what their cars would look like without having to enter a clay prototype. Typically across a car's manufacturing cycle, this can be 15 clay prototypes, each of which costs around $500,000 and 3 months to mill. That's why a car takes around 3 to 5 years to actually move from sketch to market. And that's also why most cars have terrible UI or UX inside the car, because they were just designed 5 years ago. So using AR, we can actually crunch the amount of time it takes to design a car because you can visualize it instantaneously, or you can still have a physical prototype, but rather than having to order a new model or a new prototype, that'll take 3 months to get there if I want to change the mirrors, I can simply overlay my new mirrors onto the car. I can take a chassis and just throw whatever I want on it and create any car I want, thus having a flexible, rapid prototyping process. I mean, it's almost like an agile process in physical design as opposed to digital design. That's a net new capability for almost any industry. Within manufacturing, this is what I was talking about with IoT connected systems. If I'm walking through, I was in Chicago, and you can thank me later. We're working on a project to make red Solo cups cheaper for everybody. These are the manufacturing folks that create the red Solo cups. It's only going to be a cent or two, but it matters. These machines are old, and they have efficiency of around 75% after maybe 10 years of being able to tune it right. And that's because the temperature of the day, the temperature of other machines, when they change out different manufacturing goods, changes the overall temperature of things in certain areas of the line. And if those temperatures aren't adjusted, the plastic gets too hard at an early on stage or doesn't get soft enough, and you have defects, rapid defects that slow down the production capability of these machines. There's just so many different factors to think about. And what we found was we started gathering more and more data on these machines and how they were operating to understand why their production rate sucked, to be frank. And most of it came down to the fact that these alarms are going off, the human operators simply aren't responding in time. In one case, when the mix of plastics that are going into a machine to create the infamous red Solo cup is happening, the response time to an alarm of there being an incorrect mix of plastics was anywhere from 16 minutes to 2 hours. Jeez. In my world, someone's about to get fired. I get to do the firing though. Because that's just such an inefficient way to address the fact that there's a manufacturing error. That stops the entire line, that stops every last bit of product that comes out for the next 2 hours until someone responds. With augmented reality, we can have the machine talk directly to an equipment handler on the floor saying, there's an alarm, this plastic is not loaded to the right level, respond, and we're able to decrease that 2-hour response time down to 8 minutes, which is better than the actual best they were achieving anyways. Again, this information feedback loop rapidly accelerates any kind of manufacturing process. So within manufacturing, we love AR. Sales and marketing, this is an easy one to understand. IKEA, Lowe's, Target even have recently all created these AR apps and sometimes even AR web frameworks to be able to load their products, home products, within the user's phone so I can see what things would look like before I buy them. I wish I had that when I furnished my apartment because, yeah, it would have made moving a lot easier. But Converse even, you can project shoes onto your foot. A lot of eyeglass companies or even makeup companies are now figuring out how we could bring the consumer closer to the point of purchase without actually needing to be reliant on physical location or good. Again, that's actually, if you think about what that is, that's an industry moonshot. That's something that we never thought we could do before within sales and marketing, was make someone feel like they're buying something without needing that something or someplace. E-commerce is great, but you don't actually have the goods. There's always a trepidation or hesitation before actually making that intent to purchase. Augmented reality allows you to actually feel what it's like to purchase something without needing any kind of physical overhead. Moonshot achieved. Operations. Heavy equipment. This took a while to understand, but most labor markets have an upcoming labor shortage. Japan, for instance, is, well, suffering an age crisis. Oil and gas in the US, after the oil price crash a couple of 8 years ago, they had a lot of highly skilled workers get pushed out because the oil prices dropped, they couldn't hire so many people. When the oil prices came back up again, the people who had that advanced skill set, they had to come back. That's all they really knew how to do. But younger engineers are now very hesitant to actually enter the oil and gas industry because, well, we all kind of know that gas prices are volatile. With the advent of electric cars and self-driving vehicles, we didn't know what's going to happen. So in around 5 years, there's going to be a massive shortage in oil and gas on skilled labor to operate all types of heavy machinery. So oil and gas has been investing very heavily in workforce support tools using AR. So I can wear a headset, I can understand what I need to do when I look at something without actually having done it before. That's rad. It's so cool actually because I get to build these things. And yeah, you can look at a piece of equipment and just see hands pop out of nowhere and arrows tell you what you need to do on something that would take a year plus to learn how to do. And again, going back to the behavioral analytics, we can track what people do when they do it and how long it takes them to do something so we can better optimize how things are laid out or how trainings are deployed. Services, kind of the same thing. Porsche actually rolled out an interesting solution across a dealership network in the US. Now when you take a Porsche into the dealer, they have a very junior level, and for them low wage, dealership engineer network that they can wear augmented reality glasses and connect to Atlanta, Georgia, where they have their subject matter experts, engineers that are skilled in all the different years of Porsche. So you bring your car in, they can fix it without actually needing to have a high-cost employee on site. At Deloitte, we focus on something called 10 types of innovation. That means innovating outside simply products, innovating about things like cost structure or networks. And it's really awesome to see how augmented reality plays out into innovating outside of just product, but innovating in how businesses run, how cost structures are entailed, or different networks can be relied upon. And finally, trading. So very, very downstream. Once the actual, like with Caterpillar, they make these gigantic industrial machines. Once a customer purchases it, maybe a real estate development group, this allows that real estate development group to be able to operate or repair or train other people without needing to actually go back to the OEM and contract their services. So this becomes a great innovation for self-sufficiency at heavy equipment or large industrial companies. I've been talking a lot and wanted to check in here and just kind of get feedback on probably this slide. Anything before is also cool too. But on this slide, you know, what is kind of surprising or what's expected? I'm sure some of it was expected. I'm sure some of this makes sense intuitively, but some of the things, if they're net new information, that'd be very helpful for me to understand as well. Or something's just flat out wrong. I love being called out.
One thing I was a little surprised you haven't seemed to mention is the use in, so I've done some research for writing essays for class on the use of just ability to create virtual environments that can then be easily changed on the fly in terms of like for military use of being able to train a soldier by putting him in a virtual environment that can then have like the explosions and the changing of environment on the fly without actually having to spend the hundreds of thousands of millions of dollars to actually create that in real life.
Well, for my military clearance for the work that we do for the DoD, I shouldn't mention that on screen. Yeah, I mean, most of the technology actually was pioneered in the DoD in the early 90s. The commercialization of the technology has led to other groups in the military being able to use it very easily and effectively, absolutely in terms of personnel training, but honestly, one of the biggest uptakes in the technology for the military that I've seen is in logistics. Humvee fleet repairs. F-35 Raptors, yeah, the new airplanes that are starting to roll out, so expensive to maintain. Stuff like that is the unsexy side of the military is actually what's getting most investment right now. Plus, the military has their own animation and graphics artists that do their own simulations and trainings. Yeah, they've been doing it since the 90s. Yep.
I see these are all kind of business examples. Wondering from a personal perspective, what do you think the opportunities for implementations of VR using the whole education?
Oh, I love it. Yeah, so the thing about AR and VR is that it's so broad, there's so much to talk about. It sucks having to narrow it down to business AR. VR in terms of education, I'm extremely passionate about. I graduated from Vanderbilt University, and now I'm helping them stand up a VR lab that's integrating 7 different types of courses through that, from medicine. And actually, I'll show you a project that we did for Stanford Health. Archaeology is actually, surprisingly enough, archaeology is using the hell out of VR. A lot of photogrammetry and rebuilding of experiences. I mean, I remember very fondly doing in chemistry, doing balancing of equations. And my conceptual understanding of an electron and atom was a dot with a circle. That's how I had to visualize that whole entire concept of subatomic particles that connect and make compounds. Like, being able to not have a pen and paper dot and circle and being able to move towards an actual physical model that I can interact with my fingers, that drives so much more of an acceleration in learning. I mean, even going back to this guy, yeah. Focus, working memory, engagement of different senses. I mean, truly when you're in VR, you're engaging kinetic, audio, visual, and building a muscle memory type response to things. That's learning that's vastly accelerated. And we've seen that in a traditional PowerPoint or Word document or manual-led delivery of training that typically takes 2 weeks to do, we can achieve in 25 to 30 minutes of a VR experience. Because rather than trying to learn procedure by text, we can teach procedure by action. So education is a personal favorite of mine. As I'm sure you're aware, it's very tough to sell to schools. Pearson Publishing is actually a sore point for me, because when I was first starting, I spoke earlier about the couple of ideas my friends and I were playing around with. We pursued a patent for AR-enabled textbook learning. Ultimately, to pursue the patent from provisional to full-length patent would have taken a couple extra $1,000 that me as a 17-year-old didn't want to spend. Pearson Publishing around last year just filed for that one. Really ticked me off, but I think the education sphere is moving more and more towards that. What I'm seeing is that it's tough to identify who's going to be responsible for owning and deploying technology for students. Could be the university, could be the textbook companies, could be the state standards, and they don't know who it is yet. You got something?
So my question was, in AR, like, these are opportunities that you mentioned. How far are we, like, these being widely adopted? Because
Yeah. Okay. Let me show you a little bit about what we've done, because they'll put this into a picture of. Well, actually, this is what's happened today. This is stuff that we've moved out of pilot into production, is what we say. Production as in scale deployment of 100 or more people using this within an organization. Product design, absolutely 100%. Most of my work's in automotive, also aerospace. Being able to leverage augmented, arguably mixed reality, if you want to really get into the brass tacks of definitions, but using augmented reality to supplement the design process to move away from a waterfall type building of a physical product with checkpoints and prototype reviews to an agile process of instant visualization. Real-time prototyping, same thing. Assisted manufacturing. So this is not so much augmented reality as in creating rich 3D graphics in the world around us, but assisted reality in having a heads-up display, like a single lens Google Glass type thing. And Google Glass, by the way, is back and it's crushing it. A single display in front of a worker's eye to show what they need to do or something that needs to be done. Again, the red solo cup example. It's not the most groundbreaking capability. We're not providing fancy flying arrows in the air to help these guys make red solo cups faster. It's simply alerting them that there's an alarm on line number 8 and they have to respond. It's idiot-proofing your labor force. And that is doing great. Field services. I was working with a telecom provider, and 96% of the time, but they send a truck to go repair a network site, cell tower, or something of the likes. They don't get it right. 96% of the time a truck goes out, they say, I can't do that, and they leave. And then next week another truck comes out, 48% of the time the second truck can't get it. It's usually around 3 for anyone to actually get something done. And if your average cable guy is any example, it makes so much sense now. So these field service providers, we calculated that for an investment of $5 million into the technology of AR for the field service organization, they could have ended up saving $85 million over 5 years, simply by pushing out what someone needs to do to the heads-up display. Stuff like that is mind-blowingly effective, and that's why field services is actually one of the biggest uptake areas for augmented reality. So that's an industry. The industry 4.0 is what we call it, advanced industry, digital factories, so many buzzwords. Customer experience is the second area. So this is less so much on the industrial side of things, more on selling more stuff. I think with augmented reality, the statistic is a 46% increased chance or propensity to buy with the consumer engaging with the good in AR versus going to a store. Within virtual reality, it changes the paradigm of, and I think I have a video as well of how we built a retail experience for a retailer. Rather than going to an aisle and looking at all the different goods, and honestly for me, I look at the price points of these different goods and figure out, okay, I'm not gonna shop over here, I'm looking down here. Rather than doing this price comparison and good comparison, we can take the user and put them in the actual environment they're gonna use the goods in. So for this outdoor retail goods provider, it was taking these people to camping sites and showing them different camps, different types of tents, different types of cooking gear and hiking gears, and saying, here's what you can bring with you on your hike in this environment. And there was over an 80% higher acceptance of price point for goods. So customer experience using AR and VR is another great way, and that's at the end of the purchase cycle. Okay. So enough pontificating. Here's my day job. This is what we did for Stanford Medical. Using a mixed reality headset, we connected their CT and MRI imaging data to a mixed reality headset and allowed their pediatric neurosurgical team to be able to access patient scans that are typically 2D slices that are put up as an X-ray and assemble them into a 3D model that we're able to give them full control over in space and motion with their hands to be able to manipulate. Size, shape, rotation, location are all simple enough to understand. But when you're operating on a 10-year-old girl who has an epilepsy site, it becomes very difficult to understand how they should place whatever surgical path they need to do. Being able to, I like this part, access slice by slice the patient. And you can see on the top left here, these are the actual, this is post-op. Those are the sites of the staples that we use to reattach her actual skull. We can plan with much higher accuracy when operating on this child's head, which typically we can't understand what we're going to cut through her brain matter when trying to fix this epilepsy site. We can even adjust different types of light rays that enter the scene to filter out, the softer tissues. So we can not only choose individual slices, but we can filter out softer tissues. And now you can even, over here, the eye is an easy example. The eye is not the same density as bone. And we can filter out the bone to see the eye and to see the softer brain tissue, so we can prevent accidental incursions on sites that might impair her movement, for example, when we're trying to address the site. Yeah, they love that. It's great. So that's a medical workflow. Go back to industry. Oh, there's sound here. So Lens is an end-to-end solution that we built at Deloitte alongside a couple of technology partners. And the client here was an oil and gas manufacturer. So wearing smart glasses and using a myoband, we were able to allow them to be able to access and interact with data without needing a computer terminal or any kind of physical worksheet. And so as this person's looking at the work that they're doing, there's different check steps that allow them to make sure they're following procedure. A call came in from a manager that's nearby telling them to go adjust a different site. So our boy Mahesh here goes to walk around. And using augmented reality is fantastic to present, but also to sense. So over here, looking at the machine, the headset's able to recognize what it is and present to them the information that they need to do to address the task that they've been assigned. Again, a completely digital workflow that he's able to navigate either with his hands, with motions, or simply by looking at different areas of what's around him to access the information. Checking off different steps.
Do the gloves have sensors in this example?
Wristband. So I did a project with a high-tech manufacturer that had engineering happening in Silicon Valley for processors and offshore manufacturing happening in China for the factories. And when something happened on the production line, they would have to fly someone out to China to fix the problem. Typically a 15-day cycle on the break fix, as well as 500K or more because they fly business. Lucky. So we actually helped them drive down their cost of issue resolution for this factory by 50%. You don't hear that number that often anymore in business. We're good at what we do. It's 2018, life's great, and management consulting's been around long enough to where 50% has been realized by now. We were able to drive down break fix repair cycle time by 50% by using this to be able to connect their remote subject matter experts engineers with the actual facility engineers to allow this instantaneous break fix cycle using Lens. Using virtual reality, we can also build training simulations, and we do a lot of this. This is for a chemical gas manufacturer. They have a lot of hazardous material transport that they use, and a lot of certification that goes into being able to transport, well, things that blow up. So rather than having a high-cost facility and trainers come out and typically a cost of $20,000 or more per head to certify an employee to become trained in transport of dangerous materials, we can virtualize the entire training process and build it so the user can step in and train themselves on what they have to do to become certified, as well as have qualitative analytics on the fact that someone they've completed, how much time they spent on certain tasks, things they missed, things they did well, and how that across the entire organization stacks up so I can figure out who's my best performers and my worst performers, what they're not performing at, and then target specific work actions to train them up on. Completely virtualized, I can have an entire facility that fits in the briefcase because it is virtual. This was a pilot that they did, and as part of the second phase that we have on their roadmap, we're really looking forward to giving them haptic gloves so we can actually have them feel like they're touching valves and wheels as opposed to using controllers. There's a company that makes a haptic glove that I was working with for a while. These guys, yeah, it was wild. They had a miniature dog that climbed into my hand, and I felt all four little paws as it walked across my hand, as it laid down and turned over. I felt the fur brush against my hand. Then they brought out a spider and I threw the damn thing off. Oh, the other good thing is, as you just saw, we can also, when someone does the wrong thing, help them understand that it was wrong and drive them towards correct decision making. What we can also do is, we can also randomly generate changes. I can randomly have things change every time in the scenario. I can randomly have tools shift locations so that I can teach critical thinking to an employee. Rather than teaching them this is how something's done, if it's perfect every time. Like, for example, repairing an airplane with a logistics provider, the airplanes are in service over 20 years. Over 20 years, certain parts get phased out. Over 20 years, certain things lose their color. Over 20 years, the manual doesn't teach you everything you need to know. What we can do is randomly generate changes in parts or colors so that someone's always presented with a slightly new task at hand, and they have to use their previous knowledge to be able to solve for that, thus creating a learning for critical thinking that other types of instructions simply can't provide. So life's great. Life's pretty good. It's a cool area to work in. It's an amazing area with a lot of opportunity. One of the questions I get asked a lot is why is Deloitte doing this, right? Why can't a company do it themselves? the quintessential question of management consulting. Well, if they could do it themselves, they wouldn't need us. But one of the biggest problems with augmented reality and virtual reality is that they don't understand how to actually build this for business. What we're hearing a lot of is technologists, R&D departments, innovation groups within these companies buy a license, they buy a headset, and they build something. And that's great, it works for that one person at that one moment in time. For them to convince the CIO to spend a couple $1 million on this, that's a different question entirely. That's a CIO saying, how would spending on this beat spending on a new factory in terms of return to my company for my quarterly return so I get a bigger bonus? I'm a bit of a cynic for a consultant who's working to help make big companies richer. So what we focus on is the 3 pillars of enterprise AR. And that's the 3 things that are fundamentally important to having any technology become accepted at a big company. Specifically, this type of knowledge is missing from the technologist's point of view. So the first one is metrics. Again, how do we define an augmented reality application's value to a balance sheet? It's kind of tough to do. Core IT. How do we make that work for more than just one person? How do we make that work for more than just one business unit? And finally, roadmap. How do we set things up so that the company can run with this technology without having to always call us back? I love repeat customers, but at the end of the day, a happy customer is one that doesn't have to call me again. So with metrics, and this is thinking about how do we define success for a company that's using augmented reality. It's thinking about KPIs, it's thinking about value levers, it's thinking about how many reduced truck rolls for that telecom provider can I achieve. It's about how much faster can I get something done. It's a lot of qualitative observational research of implementing a solution, observing the change, projecting that delta across the cost structure of that organization. Spreadsheets, not fun. That's how we get performance delta, and that's how we get cost-benefit analysis that helps us derive an ROI. At the end of the day, technology is great. If it doesn't have an ROI, it's going nowhere. So achieving that ROI and calculating that based on KPIs in the industry is how we have a metrics-based approach to adoption. Second thing is core IT. I like to talk about things in terms of, with ARs, in terms of an iceberg. The tip of the iceberg is what everyone sees. That's an application in the hardware. That's you using the technology. What's underneath that iceberg is everything else. It's content, it's systems integration, it's security, it's network latency. Network latency is huge. It's IT governance. There's a whole lot of things that, I mean, most companies today are digital companies. They run on digital platforms. They have information crisscrossing all sorts of different systems, from finance to HR to payroll to work instruction. Those elements are all needed. An example here would be for Target. Target has an AR application that lets you view home goods within your home to purchase them. To us, the tip of the iceberg is I download the app, I can see furniture, I can buy things, and I'm happier. What's happening on the back end is this app has to find and pull that right 3D model of the good that you selected, optimize it in terms of how big that file is for a phone, and then project that based on what phone model that you have and optimize it for the phone model. Also, what it has to do is catalog the fact that you clicked on that item so we can track the popularity of those items across who's using AR for what, as well as if you do click buy, connect to a financial payment system to collect the payment from you, put it into an intermediary that then fulfills the payment to the provider, and a logistics system to grab the good, put it into an ordering system so that it actually arrives at your front door. That's 4 disparate systems that it has to talk to for you to push buy. There's a whole lot that happens under the iceberg that people don't really realize, and that's why the complexity exists beneath the surface. Kind of the same point. A lot of my clients, a lot of the Fortune 500 group, again, are digital companies. They have plenty of assets, plenty of things and data running around their digital backbones. None of that's optimized for AR and VR. For AR and VR, you have very stringent optimization protocols. So if you want to think about virtual reality, that means I have to maintain 90 frames per second. with zero change as I move around a 360-degree environment where the light is being re-rendered every time I move a millimeter. And I have to have all this happen across 2 lenses, which means 2 separate screens, stereoscopic processing. I have to do all of this. If I'm doing a multiplayer experience, if I'm having more than one person or connected systems, I have to account for network latency. I have to account for how long it takes to get that information from somewhere else and push it across fiber optics to get to wherever I'm at. That's tough. And so we have to really focus on reducing the level of complexity of what's in the scene around us, whether it's the furniture or the Target app or nice Overwatch jacket. Anyways, there's a lot of optimization. And so developing middlewares is crucial because we have to figure out how to import things, do so in a way that maintains this latency requirement, and then finally make it available for use on an AR device within an AR application. So one of the biggest missing elements is actually middleware that helps us manage content that already exists and use it in the new interaction layer. That is a missing component for almost every last application that's out there. And so one of the things you'll start to see as we move towards this new era of AR adoption is, on the technology side, on the IT side, a lot of middlewares, a lot of custom toolkits that come out. On the consumer side, it's going to be more availability of things you can do with it. Finally, the last thing that is really required to have any kind of success with technology is a roadmap. Dan and I were just talking about in the automotive sphere, it's tough to figure out who owns the AR app. But the designers want to use AR to help them design cars faster. That's great. Designers probably don't want to manage IT. Engineers are the ones that deal with less prototype cycles. So they're the ones actually whose processes are impacted by the designer's new tools. But IT has to be the one that actually organizes the adoption of a new platform and the management of applications within different business units. So process refers to how can I reshape the way something was done previously? How can I reshape the standard operating procedure for an operation within the industry that's been happening for 10 plus years? It means I have to address the concerns of an engineer who's been at the same company for 30 years and change the way he's been doing it for 30 years. I don't have any gray, I have a couple gray hairs, but not enough gray hair yet to actually get any credence in the room of 50-year-old plus engineers. Technology-wise, that's who manages the technology. Who do you call when you want to launch an application, or who do you call when the application doesn't work? And finally, organization. When we're onboarding new people, when we're offboarding old people, how do we figure out the new adoption of this standard operating procedure? Once you understand that, you really end up having this kind of crawl, walk, run understanding for the new technology. And that's ultimately what my work leads to is how do we help clients crawl, walk, and run with AR? And what inevitably ends up happening is a focus on the crawl phase and the pilot phase, focusing on metrics, focusing on how do we define success, to rationalize the walk phase, which is how do we actually expand this and make it work as a day-to-day process? Once we do that, is how do we help this expand outside the singular business unit with a roadmap that really pertains towards enterprise adoption and governance. That's my job. I like it. So yeah, that's a little bit about AR and some VR, how it applies in the Fortune 500 space. Some cool videos about what we've done and some of the key hurdles that our clients face that we help them solve. Love to have a conversation about that if anyone has questions about it. Yeah.
Skills for people to work in this field.
So there's a lot of different, actually VR developers is the most in-demand technology skill set right now. Beats out any other technology job in the freelance marketplace. So developers, sorely needed. People who understand how to develop within Unity, Unreal, and these types of 3D engines. Designers are also highly sought after because managing someone's attention in the 3D space is tough and not understood yet. One of the biggest problems that we ran into on that first video, the neurosurgical toolkit, was what would be helpful for the neurosurgeon to have that he would use, and where do we put it, and what does it have to look like? It was, it was really tough because this neurosurgeon had been doing his job for 15 plus years. and changing his method of operating on people's brains was something we did not want to mess with. Helping him do that better was what we wanted to achieve. I'm not a neurosurgeon. I don't know how to make a neurosurgeon's life better. I mean, I would just eat healthier and don't go to the hospital, I don't know. But our designers really needed to study his operation flow within the OR. So we spent a lot of time in the OR watching him do operations, understanding where his attention goes, where his eyes go, when he reaches for something, when he calls for a technician to give him the EEG reading. That all became data that we then said, okay, how can we take those information elements that he's seeking elsewhere, bring them within his field of vision, and set him up with 5 or 6 different iterations of that so that he can choose which one, and we can start to see where he gravitates towards in terms of where his attention is available versus where it's not. He's looking at the patient, we can't put anything down here. We have to focus on putting things not up here, but maybe to the side, because if he's reaching for a tool, he can also reach for a digital tool. So understanding that visual layout is crucial for any kind of actual applicable tool. Thus, designers have a great opportunity. Consultants are also needed, strategy consultants specifically, because the people who need to start paying for AR don't understand why they should pay for it or how much value it gives them in the industry. So understanding financial modeling, but having a passion for the technology as well as an actual understanding of it is tough to find, but highly sought after. Yeah, I'd say those are the 3 most in-demand things, at least from my point of view. If you talk to the folks who are developing the technology, different types of view, things around more hardcore mathematics and graphics specializations, comp sci engineers. But from my point of view, those are the 3 things that are most in demand. Yeah.
What do you think are the biggest challenges in AI consumption when you're trying to convince somebody to go for AR as opposed to traditional methods?
The first would be like value. At the telecom company, they're like, okay, why should I spend money on this AR program when I can invest in building a bigger workforce so I can do more repairs? We drove down the numbers and said, dude, don't hire more people. 96% of the time, they're not doing it right in the first place. Solve that before you hire more. And after the cost modeling, we said, well, you have $85 million that's not being put on the table right now because you refused to invest $5 million there. That became a much different conversation than demos and presentations. That's probably the easiest way to get past initial barriers, is just saying, compared to everything else you can spend money on, this is in the top 3. The second is oftentimes security. At a lot of the aerospace companies that I work with, when an engineer doesn't know how to do something on the fuselage of the airplane, they get off, they walk to the very back of this 1,000-yard facility, go to a small room that has a security code, open a big binder of paper, find the part that they were working on, and say, that's what I have to do. Then you walk all the way back. Because you can't have digitized instructions at this aerospace site, security is paramount for them. Using AR, we can actually create geofenced areas so that when you're within this area, you can actually see the information that's tying back to something that's very local on the device. And we can load military-grade cybersecurity on that device. So it's actually probably more secure than having papers lying around. But understanding that there is security available of that caliber is tough. And finally, device costs. They're expensive. I mean, from $800 up to $3,000. Just a wide array of costs of these devices, and rationalizing a workforce of 500 people adopting a $5,000 headset, that can be tough. But that drives back to the numbers. I think those are the main points, barriers to adoption. Yeah.
Question about human factors. You talked a little bit about managing attention and cognitive skills, search space. I'm curious to know, like, what challenges you may have faced with cognitive load when it comes to trying to perceive the real world and virtual space at the same time. How that can be like a risk.
Oh, totally. I'm sitting down because I bang my knees because I bump into things all the time when I'm testing out these applications. And it's not fun to bump into things at an oil site because these are, sharp metal objects. it's tough. I mean, again, that comes down to the experience someone has designing in a 3D interface. Hiring an experienced 3D designer is tough for us, especially because there's designers that could work at Google. Saying Deloitte, I could see them just fall asleep immediately. I mean, I'm sure most of you didn't know that we do this type of work. Most of you attribute us to being accountants. My mom still thinks I'm an accountant. I don't know how. It's like, she keeps telling me to go to business school. Like, mother, I'm doing other things in life. But yeah, trying to attract that talent is tough because the talent's so rare. Because having a successful, experienced person that does 3D design, the technology hasn't been around long enough to where anyone really can call themselves a senior UX 3D designer. I don't trust that unless they've been doing it since the 80s, to be honest. So right now, the companies that are pushing the technology, Google, Facebook, Microsoft, their teams have started being very good about documentation and pushing out best practices of how do you manage attention, how do you manage asset placement, window placement. Because yeah, it's crucially important to make sure that someone's having a good experience that's informing them, but not detracting from the world around them, for them to say, this is working for me, as opposed to, okay, but I'd still rather pull my phone out if I'm going to completely remove my attention from the world to a device. It's tough. To be honest, I actually still rely on the expertise of these companies. If I'm doing a project that requires rich media or high information volume of content, I end up calling the guys at Google and saying, all right, here's what we have, here's our shot at it, go over with me, take it out for beers later, tell me what I need to do better. And it's a good thing that designers love beer.
I'll piggyback onto Ken's question. As a consultant, it used to be, now with Uber, we don't do this, but it used to be, I don't know if you had this experience of different rental car every week, if not a couple of different rental cars every week. And the seeming absence of standards for where something goes and what kind of interface affordance is appropriate for it. What appears in the center stack, what appears in the control panel. It seems like the automotives, even within Ford, can't figure out a system for where to put what information under what conditions. So I'm curious about your point of view toward, is there, we all know logo top left, we all know hamburger maybe top right, we know left rail is maybe more immediate navigation than right rail, we know footer all the way down if you're looking for the phone number. So we've got some standards for where in space to put stuff, and we're talking about a two-dimensional projection. What do you think about standards for where stuff goes in three-dimensional space?
I think, and this makes me so happy, that it's going to be based on video games. Status, weapon. It's going to come down to things that we're used to, and what we're used to is thinking about things in the context of video games that have a visual overlay. Things that are at the periphery intuitively are things that are not changing as rapidly. My attention does not need to be drawn there, but it can go there to understand something after the impact of something happened that changes my status quo. I think periphery remains to have that framework. In the center of the vision, we also don't want to place things directly in the center because that's where my eyes rest. My eyes don't want to constantly be bombarded. Things that are close by though. In the 2 years that I've seen mixed reality have more and more content, I've seen richer and richer apps fail more and more. Rather than trying to put more information places, it's more dragging the human's attention towards something and then letting them figure it out for themselves. And then having an option to select the rich information if necessary. On the oil field or the field sites, I don't want to instantly put up, here's a diagram of the machine. Chances are the person already knows that machine pretty well. What I want to do though is when he's driving down or when he's walking past, have a gentle pull of maybe a ring or a hue to the right saying, something's over here. And then a highlight of that machine saying, this is what you're looking for. And allow the human to maintain the complex decision-making that we still value in them, but enhance it by allowing them to have more than just their immediate perception. That's the first stage of value. The second stage of value would then be if they don't know, allow them to access. So that's been the successful design paradigm that I've seen, is periphery reserved for status quo things, and you can check on that if it changes. And the primary mechanism being attention, manipulating attention before accessing information. That should be the last stage. But this is in a 2D stereoscopic headset in a single monocular device. These things are very small, top right corner, and you only really pay attention if you look at them. So that's where I can actually take up the whole screen very quickly and push grab things out. I also use Uber instead of rental cars because Uber connects to my SPG account and I get hotel points and points for consultants. I saw, yeah.
Sorry, like I was listening and I forgot. Oh yeah. So for this like kind of area with VR and AR, is it important to try to get experience with this stuff beforehand and trying to apply for a job?
Yeah.
Or are they expecting to like teach you it yourself since VR headsets and stuff are expensive?
Both. I would say most academic programs now support any kind of like hardware acquisition. You could ask around at this school, you can find something pretty quickly. I also mentor a class at Indiana University, and they were asking me a couple of questions on how does these specific industries look at AR. I said, you're a student. You get to call whoever you want in the world, and they'll have a higher likelihood of answering you than they would me, because you're a student, you can request information or help. And to them, this just happened to me. I love talking about myself. I'll tell you all about myself. Anyone who works would love to tell you about what they do. So you can talk to anyone you want and gain that expertise very quickly because you're a student. Once you have that, you can find out how you can start learning about these things and do so very quickly. There's tons of free licenses, a lot of developer-less environments for building experiences. Once you do that, you'll go through the process of learning what works and what doesn't work, and you can quickly understand how to position what you say. So where even if you don't have experience, you have an opinion, an informed opinion, and that is needed at all costs before entering the space. Again, because there's so much hype, it's tough to find out who can actually deliver.
Okay.
Hoosier? No? Oh. Where we got into Overwatch jacket? I want to see what character he plays. Yeah.
It's really good. How do you stay on top of the trend, updates, and news? I know your work is already putting you in very front line, but for us, who wanted to stay on top of this whole VR domain, how are you currently doing so?
I do so by beer and flattery. I just take people out to drinks and say, tell me more about what you do. And after building a good relationship with key people at certain companies, I travel a lot. So whenever I'm in town, I check in with them, take them out to dinner, and then I get a lot of gossip. The gossip points me to new places, and then I keep learning that way. Honestly, that's what it is. I can understand how the tech giants are moving by getting the gossip from key engineers and then putting together my own opinion. Then I tell them my opinion, they tell me if I'm right or wrong. I would advise the same for you. Again, you're a student. You can LinkedIn message or cold email almost anybody at any company and just say, listen, I'm part of this class. I'd like to learn more, get your opinion. They will probably answer, and if they don't, they won't be offended. And the best part is, if you do end up having a great conversation with them, you can approach them when you graduate and say, hey, I'm interested.
That's awesome.
Beer and flattery. More than just one use, yeah.
I have a question with your on-site training AR portion. So how is it after they've gone through the tape training through AR and there's a critical failure either with the technology of AR or the critical failure with the piece of technology that they're physically working on the machine? Have you seen any rate change with that, or because like my concern with AR is that they learn the technology and they rely heavily on the technology, and then if critical failure occurs in the real world, they won't be able to actually.
Totally. When was the last time you went to the library to check out a book?
A couple months ago.
When was the last time you Googled something?
Probably a couple weeks ago, or like yesterday. I guess I don't use Google. I use DuckDuckGo, but yeah.
Okay.
It's an high school, man.
I would say that learning how to use technology is more valuable than learning the skill itself. This being said, my kids are absolutely going to learn long division and search for these in the dictionary. I value that. But if you understand how to use Google, how to query search terms, you're going to end up being a lot more informed than learning how to find things in a library.
Mhm.
Similarly with AR, learning how to leverage technology to accelerate more than what you already know
Mhm.
doesn't mean that you're on a crutch. It just means that you have an expanded skill set.
Mhm.
And at the end of the day, if the local application fails, there are connected redundancies that we build in. So especially in high cost asset areas, oil rig, quick time, otherwise something goes wrong. Yes, there's locally stored information that teaches you what you need to do and helps you through those steps. If that fails, you get this redundancy to connect to an SME that helps you walk you through that same step.
Mhm.
If all that fails, you probably weren't going to get it right anyways, and well, don't call me. I'll block a number.
Okay, so it's basically there's just fail safes with things,
Has to be.
not necessarily fail safes with skill learning and hard skill learning.
Yeah, because we're not intending to use this to replace the requirement of knowledge.
Mhm.
We're intending to use it to expand someone's skill set to new areas.
Mhm.
I suspect that as the future rolls on, that might change, where now people with net zero skill sets can pick it up and run with it. Right now, the realistic thing is that most people already are experts in their domain. We're just helping them reduce the size of the workforce or increase the efficiency, not yet replace entire chunks of knowledge.
Mhm.
But that's a good point. In the next 5 years, as the new workforce enters in, they might start relying on this from ground zero and have no knowledge until they start working on it and become familiarized with it to where there'll be some familiarity. But that's a good point.
Two things. What Overwatch character do you play? And
Reaper.
What are their steps or processes that are maybe companies like Deloitte are taking to avoid unethical processes that lead to a Black Mirror reality?
Yeah, so cybersecurity and unethical discourse is things that we are highly concerned with. I'm highly concerned with. No one cares, to be honest. Besides those who do, but typically those folks aren't the ones in positions to make calls about anything. It comes down to the designers and the developers of the application to do so in a way that makes sense. For instance, there's a lot of talk about social media and what happens when we integrate social media with AR, and now I can see everything about you. You can't really stop that from happening. You can't really, unless you have Facebook, LinkedIn, and Google, and every other social media platform block an API to export information there. But then you can probably still develop a Windows application that runs a web version of it, right? There's ways around the parameters we can set up. It's a concern though, because there's a lot of vulnerability that happens when using an AR device, especially in a connected setting. If I'm looking at you, I can capture that information before it goes back to an infrastructure, which means I can pull from the device your facial information, your shape of your face. With iPhone X, even I can pull off the contours of your face and the distance of different points. I can use that to recreate a 3D model of your face. I can use that to animate a 3D model of your face. There's a lot you can do in terms of before something leaves the device or when something arrives to the device all over the network. So my primary concern when I'm building applications is actually at the network level to protect what's being gathered and sent or retrieved. Because if that's locked down and really set up in a way that's secure, it takes a lot of burden of worry off of my shoulders, because now once that's out of the way, the real vulnerability comes down to whose device in the hands of. And like a laptop or a phone, that's only as good as the organization itself manages. So I guess to answer your question, yeah, it's never going to be perfect. I would say the biggest vulnerability is at the network level, and it comes down to the developers or the designers to create the application in a way that is ethical in terms of design and ethos, and not throwing ads in the center of your vision unless you click it. But it's also going to be just as vulnerable as any other device that we have, and the same risks go into having social media on our laptops to judge people, as well as having them in the field of vision to judge people. Good question, though. Yeah.
The Overwatch guy, he said that the champ that he plays or the character that he plays is robot. So,
Bastard.
yes.
I get wrecked by Robot. Okay. Overwatch is awesome. I'm such a fan of the game. Yeah, any other questions? I mean, also this is AR aside, Deloitte Digital is doing a lot of other development in these types of technologies and applications of it. So happy to chat afterwards if you're scared by crowds, which you shouldn't be because you've been in this class longer than I have. But no more hands. I'll just go ahead and say thank you guys for your time and attention.
Thank you. That was awesome.